Okay, so today we are going to learn assembler directives. Assembler directives are the one which are used to tell something to your assembler. They are also called pseudo opcode. What do you mean by pseudo? Pseudo means duplicate. So they are not actually instructions or they are not actually opcode, but they are pseudo opcode. What that means? They are not executed by your microprocessor. They are the one which are used by your assembler. There is a difference between assembler and microprocessor. Assembler is a program runs inside your microprocessor. Understand? Yes. Same way you are having compiler in C language. Here you are having assembler. Understand? So all these are kind of keywords which are used by your assembler to understand your coding style. So to make your programs structured and better, we are using assembler directives. Understand? Yes. They are not instructions, they are not executed by your microprocessor. Clear? Yes? Okay. Now the first assembler directive is segment and end. So when you write down the program, you need to tell your assembler that this is my code segment, this is my data segment. To do that, you are using these two keywords. So suppose I am using data, segment, data, ends. Whatever I am writing over here, this is considered as one segment. Understand? Though I have given name data, and if I write down program over here, it is my choice that I want to make it the data segment or the code segment. Name is in your choice. So instead of data, I can use my name also. Understand? But when you write down something like this is creating virtual segment in your program. When you officially assign some segment name to it, it is become physical segment. Understand? So in your program, if you want to declare any segment, name, segment, name, end of segment. Whatever you are writing over here, that is treated as single segment. Understand? This simplest thing. And is another assembler directives which tells your assembler that your program is over at this point of time. Understand? So whatever you want to write down after end will be treated as normal statement. Your assembler will not execute it. Understand? So you can write down the logic of your code, some comments after end, and it will not executed by your assembler. Understand? So it is simply indicate that here is the end of your code. Normally we have one keyword called start in code segment, and we are writing end start at the end. This is not assembler directive. This is your label. This label is same as a main label that you are having in C. In C language, what happens? A compiler first go to main and start executing. Same way, start is a label which tells your assembler that start your execution from this point onwards. Understand? And your end is always associated with start. That doesn't mean that start is also assembler directives. It is not. Start is a label. End is your official assembler directive. Clear? What we have studied till now? There are three assembler directives: segment, end as, end. Clear? Okay. Now next is assume. As I said, when you write down data, segment, data, end as, it is just a segment. But to make it a actual the data segment, you need to assign it. Yes? So for that you are using assume assembler directive. So how you can utilize it? Assume ds colon data. If I write down like this, what it do? Whatever the data segment is there, virtually now it is associated with actual data segment because your ds register will contain that value. Understand? Yes. Same thing you can do in your 8086 by writing move ax comma data move ds comma ax. These two lines are doing the same thing which your assume assembler directives do. Understand? Yes. So assume assembler directives actually allocating your logical segment to actual physical segment. This is what the work of assume directive is. Clear? If you don't want to use assume directives, still it will work. You need to write down these two lines. It is as simple as this. Clear? So when you write down these two lines or assume directive, it tells your assembler that now data is my the data segment, code is my the code segment. Understand? Instead of data, if I have used sub1 and if I write down assume ds colon sub1, then my sub1 is actually a data segment. This is what I am telling to my assembler. Yes. Okay. So that is your assume key. This one thing is okay. Now pay a little bit of concentration because this is important as far as examination is concerned. All of you know function? Yes? Normally your function comes at least 2 times in your code. Suppose this is my function, I have written some lines, this is my function definition. Yes? And I need to call this function, suppose f, so I call it from somewhere. So function call is there and there is a function definition. Yes? Same way, if you want to create subroutine or function in assembly language, then how you can create? Concentrate. You can write down call xyz, where xyz is the name of my procedure. Okay? And the word is PROC, procedure xyz, whatever is the procedure, and PXYZ. So this is how you can declare procedure in assembly language. Whatever your code you can write down in function, that you can write down over here in assembly language. Yes? You declare a procedure PROC and to end the procedure. And if you want to call this procedure, you can write down call the name of the procedure. Yes? This is the syntax. Clear? Yes? This is easy. Same thing can be done using macro also. If instead of procedure, if I write macro and m, this is doing the same thing. For calling that macro, you simply need to write down the name of that particular macro. So you are simply write down xyz and it will execute this part. Yes? Procedure and macro both are doing same kind of thing. Example is you want to find out a factorial. In my code, I am executing these lines. Now I want factorial. I call a function factorial. It will go to factorial function, execute it, come back over here. Yes. Same thing can be done using 2 different methods. One is called procedure, one is called macro. There are 2 ways, so there must be some difference. Okay, so try to understand what's the difference between procedure and macro. Concentrate over here. If I have written this code, this is my main program. Here I am having call xyz function or procedure. Understand? That procedure is written over here. So what happens? Your microprocessor execute this program. When it comes over here, my value of IP will get changed. I comes over here, execute this part. Again the value of IP will get changed. I come on this line, execute my another remaining program. Yes, this is what happens when you call a procedure. But if here is my name xyz, this is the code of xyz. If this is a macro, I am not jumping anywhere, I am not coming anywhere. This code will get replaced over here. Understand? So I am not going, the code is coming to my code. Yes. Now you people tell me which one is better and why. Procedure is better or macro is better? Yes? Macro is better according to your choice. Why? You don't need to jump anywhere, you don't need to come back. But what if I am calling the same function? As you know, functions can be called multiple times. If I am calling the same function 100 times in my code and the code of xyz is 10 lines. So my actual code becomes 10 into 100 times bigger. Understand? It will occupy more space. Yes? So if you are having a limitation with the size of your code, macro is not good. Get it? What is the advantage? You don't need to jump anywhere, you don't need to come back anywhere. So your time to go and come is get reduced. So if you want something faster, macro is good. But if you want something shorter, procedure is good. Understand? Both are having their own advantages and disadvantages. Again, concentrate. This is called branching because your IP will get changed whenever call will come. So your pipeline gets failed over default scenario. So every time when procedure is there, your pipeline gets failed. And if your pipeline gets failed, it is slow always. So procedure is slow. Macro is faster. Macro will require more space. Procedure will require less space because only one time it will get required. Yes? So tell me the situation where macro is based and tell me the situation where procedure is based. Simple example. If this is a loop, in this loop I am calling one function multiple times. In this kind of scenario, macro is better because the code will replace only once and I can call it multiple times. Yes, but if I am having a program where from 100 different locations I am calling a function, procedure is better. Clear? Yes, a program where you can call it a function multiple times, procedure is a better choice. If you are calling the same function from a loop, macro is a better choice. Understand? Yes. Which one works faster? Macro. Which one is slower? Procedure. Why it is slower? Because you need to jump and you need to come back. Yes? You need to change the value of IP every time. Done? This is what procedure and macro do. So I hope this much part is also clear. Yes? Oh, now in C language you are having data types. Yes. So if I write down integer a equal to 10 in my C language, what this line will do? Your compiler will go to memory, allocate 2 bytes of location, give it a name A and store 10 inside that location. This is what your compiler do. Yes? By seeing integer, your compiler knows that you require 2 bytes. Yes? By seeing 10, it will store 10 to it. And by default, it is giving A to this location. This is what happens when you write down integer A equal to 10 in C. Same thing can be done in assembly language also, and these are your data types. Okay, so if I am writing A db 10h, what it will do? Data byte. So 1 byte will get occupied, give it a name A, 10h will get stored over here. Understand? If I don't want to store anything, I can simply write down question mark also. So it will remain empty. If you want to initialize, you can initialize also. If you don't, you can write down values also. Understand? db is for data byte. dw is for data word. So it will occupy 2 locations. 8 byte, total 16 byte. Understand? 16 bit. Clear? d double word. So total 4 locations will get occupied. Understand? dq quadruple. Total 64. So 8 locations will get occupied. Understand? And t for 10 and terabyte, whatever you can say. So total 10 bytes will get occupied. Simple. So based on your requirement, you can choose any of these. Our 8086 is 16-bit microprocessor. What do you mean by that? You can process 16-bit data in a single clock cycle. So we hardly gonna use anything above dB or dW. But in case of multiplication where you are multiplying 2 16-bit number, your answer will be more than 16-bit. In that kind of case, you might require DD. Other two will not use it, but for future processor they have already launched during this language itself. So you should know this. Okay? So what are the data types? dB, dW, dd, dq, dp. For 8086, it is simple memory. 8086 don't know anything about character, string. Everything is number. Understand? In 8086, everything is number. So if you write down even A, it will take the ASCII value or ASCII value of A. It is not considered as A as a digit. Understand? Everything is number only. Clear? So we only care about bytes. This much stuff is okay? Yes, so these are your data type. Next is EQU. So if I write A, EQU 5H, what do you mean by this? Equal. EQ is nothing but constant. I hope all of you know what is the importance of constant in C language. Why you are writing constant? What is the difference between constant and a variable? If I am declaring constant integer A equal to 5, instead of that I am writing integer A equal to 5, and I will not change the value of 5 throughout my program. Will it work? Yes. Then why you need constant? How it is good? चेंज एम भी नहीं करूँ तो simple variable बनाओ. Why you want constant keyword? What is the advantage that you get? At least I am having the flexibility that in future I can change it. By writing constant you can't change it. Then what is the advantage of making anything constant? Okay, constant. If I write down integer a equal to 10, what my microprocessor do? This is my memory. This is a. 10 is stored. In my program I have written b is equal to a. So here the value of a will get copied into b. How it will get copied? I will go to symbol table. Here the address will come. Your compiler will replace the address of variable a. It will go to this address. Whatever is stored on this address, that will get copied into b. Every time when there is a variable, you need to replace that variable with address. So every time your assembler or compiler go to that address, fetch the value and replace in your code at runtime. Understand? Your variable value can get changed. Yes. That is why it is variable. So when this code is converted by a assembler or compiler, every time at runtime your processor goes to that memory location address, fetch the value and replace that value over here. Understand? Yes. So if I am declaring anything as a variable, every time I need to go to memory, fetch the value and replace it. This is what I need to do. Your memory is different than your microprocessor. This is my microprocessor, this is memory. I need to go here, fetch the value, come back. I need to use my data bus. Yes. I need to use my address bus. Yes. It requires time. What your constant do? When you declare something as constant, before runtime, your assembler or compiler in that case replace this a with 10 itself over here. Yes. So I don't need to go to memory and check what is the value of a. Simply it is 10 already written. So at runtime it will work very fast. Get it? It is same as direct addressing mode and immediate addressing mode. In normal case, if this is my normal variable, this will be my direct addressing mode. I need to go to memory, fetch the value, replace it over here. Yes. In case of constant, the statement actually becomes like this. So I don't need to go anywhere, I don't need to come. Processor knows that I need to copy 10 into b. Get it? It works like immediate addressing mode. So your constant makes your working faster, and that's why we are using constant keyword. Get it? Yes? Yes or no? Yes. So that is the importance of constant. So same thing, if you know that something is not going to change throughout my program, I want to make it constant. In assembly language, if you want to make something constant, you can use EQU. Understand? No need to give data byte, because by seeing this number, your assembler knows that it is 8-bit data or 16-bit data. Understand? Yes? So EQU is also done. DUP. DUP is used to define array. Okay. So A, DB, DUP, 5H, question. If this is the syntax, what I am doing, as it is DB. So I am occupying 8-bit. How many times? 5 times. So there are 5 locations. Okay? And all are in question mark, so I am not writing any data. If I am writing 99H, all these locations will copy with 99H. Understand? This is how you can define your array. Get it? Another way of defining array is A, DB, 11H, 22H, 33H. This is also a way by defining array. There are 2 ways, but when you want to declare an array and you don't want to initialize anything, DUP is a better choice, right? अब हमारे 5 का array बना हुआ है, और हमारे value कहीं नहीं आपकी I need to write down like this, question mark, question mark, question mark, question mark. It is better to write down A, DB, DUP, 5, question. It looks good. It is a better way of defining. Yes. So DUP is used to define array. Clear? Oh, now there is one assembler directive called align or even. Both are same, but we will study this when we will study memory banking. Okay? So whenever we cover memory banking, you need to give me a reminder that sir, what is align, what is even. Teach us. Okay. So these are the assembler directives used with memory banking. Okay. It is very important as a good program. So we'll study when we cover memory banking. So just give me a reminder. Okay. Next is bytepedia, wordpedia. Concentrate. Now give me the answer. Move AH comma square bracket 1 2 3 4 H. This is 8-bit instruction or 16-bit instruction? But this is doing 8-bit operation or 16-bit operation? Move AH comma square bracket this. Whenever you see square bracket, it reflects memory. From memory you can fetch 8-bit of data, 16-bit of data, your choice. Understand? Now this is 8-bit or 16-bit? 8-bit because of AH. Yes, if I am writing move AX comma square bracket 1 2 3 4, 16-bit. Move square bracket 1 2 3 4 comma PL. 8-bit or 16-bit? 8-bit. How you can say that? PL. So only 8-bit data will go to this location. If I write PX, 16-bit. So from registers you can say that your operation is of 8-bit or 16-bit. Understand? Yes. But suppose, now concentrate here. MUL AL comma BL. 8-bit operation or 16-bit? 8-bit. Both are 8-bit numbers. Yes. Move BL. Move BX. Yes. Problem comes when you write down MUL square bracket 1 2 3 4 H. So I want to multiply something a register with this memory location. Okay. Now you want to multiply 8-bit or 16-bit. Now this is not clear from this instruction. Understand? Yes. From memory location you can't say it is 8-bit operation or 16-bit operation. That is not possible. And in this instruction it is not mentioned that it is 8-bit operation or 16-bit operation. So in this case, if you write down bytepedia, it will do 8-bit operation. If you write down wordpedia, it will perform 16-bit operation. That's why these pointers are needed. Understand? And in case you don't remember this and you don't write this, still the instruction is valid. It will perform by default 8-bit operation. Okay? Clear? So when you require bytepedia and wordpedia, when your instruction is not clear, it is ambiguous that it need to perform 8-bit operation or 16-bit operation, you yourself need to tell that it is 8-bit operation or it is 16-bit operation. Yes? Clear? So this is bytepedia, wordpedia. Next is ORG. Now by default, if my data segment is this, I have written something over here. It is stored randomly in memory by your assembler. It will assign some space and your data will get stored. Yes? But if you want that my data should get stored on specific location only, then you can write down ORG 200H. Whatever you write down after that will start from location 2000. 2000 is your offset. Understand? Yes. Suppose you are having a data set. It starts with random location. Microprocessor will assign the memory. I have stored something over here on 0000. Second variable store on random location. Yes. But you want that in data segment I should start my variable on location 1000 only. Then I can write down ORG space 1000H. So whatever I write down after that 1000H will get stored on that particular location only. This is how ORG works. It is called origin. So next your data will get origin from that particular location. Yes. We hardly need to read it, but for the exam purpose you should know this. Clear? Yes. Next, near and far. Okay. As we know, in 8086, how many segments are possible? How many types of segments are possible? Core, data, stack, extra. How many segments possible? Infinite. It can be many. Yes. There may be 2 core segments, there may be 3 data segments possible. Yes? Yes. Okay, this is one segment. I am jumping from this place to this place in my segment. This is called intra-segment jump. What is it called? This is one core segment, this is another code segment. I am jumping from this segment to this segment. I am changing the segment. It is called inter-segment jump. Understand? If I am jumping in same segment using procedure, it is called near jump. If I am jumping from this to this, it is called far jump. Understand? Let's take some practical example. You are using WhatsApp. Yes? In WhatsApp, if someone messaged you and you reply back, I am in lecture, don't disturb me right now. This is your intra-segment jump. Message facility is given by WhatsApp. You are replying in WhatsApp itself. It is intra-segment jump. Yes? But someone told you to capture the photograph of sir and send me right now. So you open your WhatsApp, open the camera app. Now camera is not directly available inside your WhatsApp. WhatsApp is actually accessing your device camera, which is given to the OS of that Android or iOS. So in that case, it is outside your WhatsApp. You need to access the camera, capture the photograph and take the photograph inside your WhatsApp. Yes, this is inter-segment jump. Understand? So when you write down some procedure in assembly language, depending on your requirement, you can write down near or far. It is not mandatory again. By default, it is near jump and you are jumping in the same segment. But when you are jumping into another segment, you need to write down it is far procedure. Otherwise, it is fine. Clear? Yes. Now these are the last two. We'll come to offset first. Again, offset is hardly used, but still, just for your knowledge, you should know what is offset. Okay, A is equal to 10. I have done A, dB, 10. Understand? So A is a variable stored in this memory. Here is a name A, value is 10. Yes? Yes. If I write down move AX, A, that is wrong instruction. A is 8 bit, AX is 16 bit. AX, A. Suppose AX will get 10. Yes. Yes. I don't want this value. I want address of it. Sometimes you require address also, pointer. Yes. So what I want? Address of A, data segment colon offset. So I require that offset. Yes? Yes. So if you require this offset, move AX. Offset will be always of 16 bit. Yes, comma, offset of A. Now if you write down this thing, it will not copy 10. It will write down the address of A into AX. Understand? Yes, this is what is the use of offset, but we don't use it because there is an instruction LEA, load effective address AX, A. This will do the same thing. It will give the address of A into AX. Understand? Throughout our programs, we are using LEA instruction instead of using offset directives. Clear? That instruction is already available. That's why this is not used much. But this is what it do. It will give me the offset address again of 16. Yes. Now last, based on your programming, you can choose a model in your code and you can write down. I am gonna use this model. Normally, as a student, we are not going to use big programs, so we use small model. Dot model small. If you have seen the assembler carefully, EMU8086. You can choose multiple ways of writing code. You can use exe, you can choose B. When you go and check EMU8086, you can choose any of the method to write down your code. In that code, initially you can define that you are going to write down a code which is small in nature, medium in nature or large in nature. Okay, just to tell your assembler that I am going to make a very big program. Yes, so if you write down dot model small, your assembler will allocate 64 KB for your data segment, 64 KB for your code segment. Understand? Yes, our programs will remain in that region only. We are not going to write something bigger than 64 KB. Clear? If you write down medium, in that case, your data will be 64 KB. Okay, your code more than 64 KB. In that case, you can use medium. What are the applications? Like you want to write down a program for AC. In AC you are having very limited data, temperature, on, off, basic data. But the program is very big. You need to do communication, you need to up the temperature, down the temperature, fan off, fan speed increase. Get it? So data is less, program is bigger. In that kind of case you can choose medium. And large, you have lots of data and you have lots of coding. In that case you can go for large model. We are not going to utilize it. Just for the sake of knowledge you should know this. In exam if theory comes, you need to explain all these assembler directives. Clear? Yes? Yes. Last, just for the sake of revision, assembler directives are used by your assembler. They are not executed. They are not instructions. They are pseudo opcode, pseudo instructions. Understand? Yes. So this will give my assembler the idea that what I want to do with my program. That's it. Yes? Yes. Clear? Thank you.